This week we work with quadratic functions and polynomials, so I'll do an example of each. This question asks us to sketch 3x squared plus 5x take 1. Now you might think that sounds fairly straightforward, but it's a fiddly one, so that's why I've chosen it. Firstly, I want to find the axis of symmetry. There are various methods you can use to get enough information to draw the graph, but I need the turning point. Completing the square to get this in turning point form would be very fiddly, so I would prefer to find the axis of symmetry. The formula is negative b over 2a. b is 5 and a is 3. So 2 times 3 is 6. Now that's the equation of the axis of symmetry. It's also the x value at the turning point. I want the y value as well, so I'm going to sub that into the function. And I'll get 3 times negative 5 over 6 squared plus 5 times negative 5 over 6, take 1. Use your calculator here and you'll find it's negative 111 over 36. Therefore, the turning point is at negative 5 over 6, negative 111 over 36. It's not a bad idea to know what they are as decimals because you need to draw it. And this is easy enough. You know, negative 5/6 is almost at negative 1. But negative 111 over 36 is roughly negative 3. So put it into your calculator so that you know what size it is, and then you'll be able to set your axes up to fit it on. So we've got the turning point. We now need any axis intercepts. The y-intercept is straightforward. It's negative 1. But I need to know any x-intercepts. So I shall use the quadratic formula to find those. Now, quadratic formula, x equals negative b plus or minus square root of b squared take 4ac over 2a. Negative b is negative 5 plus or minus square root of b squared, 5 squared, minus 4 times a times c. 4 times a times c. And it's over 2a, which is 6. So I've got sufficient working here. I'll keep going through it. Negative 5 plus or minus square root of 25 plus 12, which is 37. So negative 5 plus root 37 over 6. They are my two x-intercepts, one using the plus, the other using the minus. But again, you need to know what they are as decimals so that you can plot them onto the graph correctly. And I will write these down because they're not as easy to remember as the previous one, which was our y value of the turning point. So if you use your calculator, you'll find that you get 0.18 and you also get negative 1.85. Over the page, I'll draw up the axis and then I'll sketch the graph with you. So I'll begin by placing the turning point. It was negative 5 over 6, about here, and the y value negative 111 over 36, which was roughly negative 3. That will be about here, and turning points need to be labelled. That's in and labelled. The y-intercept was negative 1. That really should be labelled. It's fairly clear that that's at -1, but if you want to be even more particular, you can label that. And the x-intercepts, we had 0.18, which is about 0.2, so that's about there. And we also had -1.85. I'll put that there. I'll label those in a minute. So draw a quadratic shape through those points. Okay, that's good enough. Now the x-intercepts, they came from -5 plus or minus root 37 over 6. So this one is -5 take root 37 over 6. And please don't label these with the decimals, use the exact form. And this x-intercept is the bigger one, so it's got to be the one with the plus in the middle. So -5 plus root 37 over 6 is the x value, 0 is the y value. So just a quick check, turning points labelled, y-intercepts labelled, and both x-intercepts are labelled. And throughout this subject, that's going to be assumed in any graphs that you draw. Certainly that the intercepts are labelled, and if you have a turning point that you're able to find, that too.